final lesson of the Integrated 2 school year. Integrated 2, Chapter 12, Worksheet 2, talking about permutations versus combinations. So, really kind of confusing stuff, but if you stay on top of it, it's not too bad. I would definitely encourage you to fill out that note sheet and sort of keep that thing handy as you're going through this. That way you can keep the difference of the two in order. But essentially, what these are is ways of kind of putting things in order, and sometimes order matters and sometimes order doesn't matter. And that's kind of what's going on here. So when we are talking about permutations, we're saying order matters. And when we're talking about combinations, we're saying order doesn't matter. So what do I mean by that? Well, let's go ahead and look at a couple of examples. So here it says, state if this is a permutation or a combination. So the first one, a team of 8 basketball players needs to choose a captain and a co-captain. Well, does it matter which one's the captain and which one's the co-captain? Is there a difference? Is order matter, right? If player 1 is the captain and player 2 is the co-captain, or is player 2 the captain and player 1 is the co-captain, does it matter? I would say, yeah, it probably does. Especially to the people that are the captain, or the co-captain. So I would say that this is a permutation because order definitely seems to matter here. Where when we go to problem 2, it says Rob and Mary are planning trips to 9 countries this year. There's 13 countries they would like to visit. They're deciding which countries to skip. Well, does it matter which order that they skip the countries in? I mean, they're not going to go anyway, right? Now, if we were talking about what order they were going to visit the countries in, I would say it's a permutation. But we're talking about the order that they're not going to visit. And who will ever know if they decided to throw England out or if they decided to throw Spain out first? It's irrelevant. They didn't go to them. So in this one, order would not be important. It doesn't matter the order that they eliminated those countries. What matters is that they're not going to those countries. So that's the difference between a permutation where order matters and a combination where order doesn't. So how do we figure out what these odds are? There's something known as a factorial, and we definitely need to talk about what a factorial is before we begin this. And a factorial, for example, would look something like this. And it has this explanation point. And this is a mathematical symbol that it essentially means it's 5 times each number down to 1 below it. So it's going to be 5 times 4 times 3 times 2 times 1. Now, if you watch the Chapter 12 Worksheet 1 video, there was a problem where we had to put the students in order of a picture, right? And we had 5 choices for the first spot, 4 for the second, 3, 2, then 1. That was a factorial problem. So that just means 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. Or if I had a 3 factorial, that means 3 times 2 times 1, 3 times 2 is 6, times 1 is 6. If I had a 2 factorial, that just means 2 times 1 is 2. And so on and so forth. But we need to know how to do factorial math because it's really going to help us shorten solving permutations and combinations. So what do we need to do here in order to calculate? I was kind of counting on this to disappear. There we go. So what do we need to do in order to solve permutations and combinations? So we have these 2 problems. That's a bummer. I should have got rid of that there. The math for a permutation, there's a formula where a permutation ends up being this equation. We get n factorial divided by n minus r factorial. So I think a great question is, well, what is n and what is r? And n is going to be the number of choices available. And r is going to be the number chosen. And we're going to compare that to a combination. And the formula for a combination is going to be n factorial. It's a very similar formula, it's just slightly different, over n minus r factorial times r factorial. So just a little bit different of a formula. The only thing that's different is this added little r factorial on the bottom at the end. So what we need to do is we need to read through the problem, decide if we think it's a permutation or a combination, and then figure out what n and r are and put them in this equation or this equation and solve. So if I look at a problem like number 5, it says Castle and Joe are planning trips to 3 countries this year. There's 7 countries they would like to visit. One trip will be 1 week long, another 2 days, and the other 3 weeks. So is order important? I would say it's absolutely important. If you're going to spend 1 week in one country and only in 2 weeks, in another, and only 2 days in another, yeah, I mean, it would matter which country you're in for however long, right? If you're in Italy for 2 weeks, you can do more stuff than if you're in Italy for 2 days. So I would say this is definitely a permutation. So the question is, what is my n and what is my r? And again, my n is my number of choices available. So it looks like I'm choosing between 7 countries. And it looks like I'm going to choose 3 countries. So my n is going to be 7 and my r is going to be 3. Now I'm going to go ahead and I'm going to set up this equation. It's going to be 7 factorial over 7 minus 3 factorial. Well, 7 minus 3 is obviously 4 factorial. And I'm going to show you a neat little thing with these factorials that is kind of a cool little shortcut. So this is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Now you'll notice I kind of put this overneath because what's 4 divided by 4? It's 1. 3 divided by 3, 2 divided by 2, 1 divided by 1. These all cancel each other. All I really need to do is multiply 7 times 6 times 5. So 7 times 6 times 5 is a pain, but 6 times 5 is easy. That's 30. And 7 times 30 is 210. So it looks like I have 210 ways of choosing this, right? So that would be my solution because this is a permutation because order was important. So I used my permutation formula and solved it. Now my combination formula. And so I think I've let the cat out of the bag. This is indeed a combination problem. So there's 110 people at a meeting. They each shake hands with everyone else. How many handshakes were there? Well, there's a lot going on with this problem, but essentially I need to figure out what my n and my r are. So the question is, what's my n? How many people can I choose from? Well, it looks like I can choose 110 people. And how many am I choosing? Well, only 2 people shake hands. So that's going to be my R. I apologize pausing of the video. It was interrupted in my own thoughts. So where we left off as we said there was 110 people and we were choosing 2 people to shake hands and they need to shake hands with everybody else. So I guess you could make the argument that R is 108, which my notes seem to, but I feel like R should be 2. But long story short, we'll get the same answer either way. So there's 110 people to choose from. And I'm going to put 110 minus 2 factorial times 2 factorial. Well, I'm not going to write this whole thing out, but essentially it's going to be 110 factorial over 108 factorial and 2 factorial. So if you think about this, 110 is 110 times 109 times 108 times 107, and I'll put dot 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 because it goes down to 1. Well, this 108 factorial is 108 times 107. dot, 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 all the way down to 0. So these are going to cancel each other's out. And what I'll do is I'll just kind of move this 2 factorial in front. So it's going to be 2 times 1, which is obviously just 2. So long story short, this is the only part of this equation that works. And I hope you guys are following what happens here and how they all cancel out and makes it a little bit easier. But I just need to multiply 110 by 109 on top, and then divide that by 2, because 2 times 1 is 2. And I get, I didn't do that right, so 11990 divided by 2, I get 5,995 ways to shake hands. So if you have a room of 110 people and you ask everybody to shake hands, it could be a longer process than it appears. So there we go. We have our permutation formula. We have our combination formula, an example of each. So the real trick in this worksheet is going to be to determine if you're looking at a permutation or a combination, and then it's going to be to figure out how many choices are available and how many are chosen. And once you have that, the rest sort of fills itself in and becomes, I think, a little bit easier. So good luck on this one. Have fun with it. Do the best you can. I struggle with this stuff at times, so if you do, don't feel bad. And hey, congratulations. That does it for the school year, except for the final. Talk to you guys. If you have any questions, let me know.